So let me show you what I've put together. I'm using Bedrock and Elasticsearch, and I wanted to, since we've started off with RAG, I wanted to just show you what is the easiest way to get search, or specifically vector search, going here. And the example that we'll be using is, I normally stick to Star Wars. Who remembers what the quote at this point in the movie is? Everybody should know this. Yeah, but what is the quote at this point in the movie? Yes, these are not the droids you're looking for. This is our example sentence that we will be working with. So I have set up Bedrock, and I'll use Titan embeddings, and I have connected that to my Elasticsearch instance. And you have to trust me that I ran these commands. I just took out the API keys because I don't want to share those in the presentation, but we have added that already. So we have this inference endpoint in Elasticsearch that basically redirects to Bedrock. So we'll just call Elasticsearch and it will talk to and work things out with Bedrock in the background. And what we'll do then is we'll take our Star Wars quote, we'll do standard text search BM25 that has been around for decades. We'll take a look at that, and then we'll also take a look at the vector embedding, and then we'll search both of those. So I'll go ahead and create this so-called mapping or schema. And now I'll show you what you would get in classic keyword search and how that would work. So if I take the sentence, these are not the droids you're looking for, how that gets stored in classic text search is like we're using tokenization. So we break up the words, we remove stop words, we do stemming where we reduce it down to the word root. And the tokens that remain basically as a droid you look. And these are the tokens you can search for. And this works very well if you have exact matches. The problem is if you have any vocabulary mismatch, like you search for machine instead of droid or Android instead of droid, it will not really match. So if you have exact matches, classic keyword search will work very well. If you do vector embeddings, not so much. Let me index this document, and then I have a second example with, no, I am your father. We can retrieve this, and you can see here, these are not the droids you're looking for. And you can also see the dense vector representation of this same text. So it's this huge array of floating point values. This is the vector representation of our text. All I've done is basically I've stored my documents, and because the inference call went to Bedrock, Bedrock created that dense vector representation, and I just stored it with my documents here. I didn't have to specify anything out there anymore. And now I could search, for example, for, let's say I search for the droid. If I search for droid, you will find with a regular query, these are not the droids you're looking for because we have this matching droid. But for example, if you would say you search for robot, the keyword search doesn't find anything because droid and robot are not the same words. You could set up a synonym, but you would potentially need to set up a lot of synonyms. It is kind of tedious. This is where vector search will then shine. So here I'm running the same query with robot against the Titan dense vector embedding. And now it will retrieve, these are not the droids you're looking for. It will also find the, no, I am your father. That's kind of the funny aspect of dense vector representation, that everything is very far from everything else, but everything is kind of matching. Because it's just a dense vector representation. And even if it's very, very far, it's still at some distance, but the droids are closer than the father, or that quote is closer here in vector representation. You can also make this more interesting. For example, here I'm searching for dad, and that will find my no, I am your father quote, obviously first, because dad and father are a bit closer. You can even make this more complicated and combine vector search and keyword search. For example, here I'm searching for droid in the keyword search and for Android in the vector search. And as you will see, these are not the droids you're looking for, matches both of them, and has a much higher score. That is how relevant it is. Versus down here, the no, I am your father, the relevance is much, much lower. But this is the very quick look of how you can use Bedrock for the dense vector representation. You don't need in your queries or when storing the data, specify the model or work around the vector model or representation that you have. You can just query like you always had or did in the past. It will just call out to Bedrock, get the vector representation, do either the storing of the data or the query, and you're done. And that's it.